This is 6-30. It says solve each equation below. Letter A has 4 to the x equals 1/2 to the x minus 9. So there, I can think of several ways to solve this. I think the way that's easiest to explain is that if I could get both of the bases, on the left hand side the base is 4 and on the right hand side the base is 1/2. If I could get both of the bases to be the same number, then I could just equate the exponents. I could set the exponents equal to each other. In other words, if this were 4 to the x and that were 4 to the x minus 9, then I could just say x equals x minus 9 and I could solve for x. Well, so I think the easiest way to get the 1/2 and the 4 to be the same number is to remember 4 can be written as 1/2 to the -2 power. How did I figure that out? Well, no, let's not do that. 1/2. If I had 1/2 squared, that would be 1/4, right? But when I make it negative squared, or to the -2, then it flips it upside down, right? So that gives me 2/1 squared. That's 4. So what I'm trying to say is that instead of having a 4 to the x, I want 1/2 to the -2 to the x. Why do I want that? Because I want my bases to match. Because if my bases match, I can set the exponents equal to each other and solve for x. So I'm almost there. I rewrote 4. It's raised to the power of x. So basically I could just write it as 1/2 to the -2 times x is -2x. See, now I have my two bases matching. So then I can just, if 1/2 to the -2x is equal, this equal sign says it's equal to 1/2 to the x minus 3, well, these two must be equal. If the bases are the same and they're raised to those powers and the amounts are equal, I can basically get rid of these bases right here, and I can just find out what x is by going -2x equals x minus 9, right? And I can just solve for x. Here I added 2 to both sides. 2x. That's where the 3x came from, x plus 2x. And then I guess it looks like I added 9 to both sides. And that's how the 9, and then I divide both sides by 3, and I get x equals 3. So that's the answer to letter A, x equals 3. The next one, it was, I wrote that x out there. It was x over 3 over x, sorry, x plus 3 over x plus 2 equals x plus 5 over x. Well, that's a problem. You could, some people might want to subtract this fraction on both sides and just deal with it, you know, with the fraction. And that would be a way to do it. You could do it that way. I chose to do fraction busters on it. So basically I'm going to multiply each term by x. Because if I multiply each term by x, it's going to get rid of my fractions. Because see, look, x over 1 times the first fraction, the x's cancel out, and I'm left with x plus 3, right? And then x times 2, well, that just gives me 2x. And then x times this last fraction, the x's cancel out, and I'm left with x plus 5. So that's fraction busters. I did mine that way. There's other ways to do it if you want. And then I added like terms, so 2x plus 1x is 3x, and there's my 3. Okay, and then I'm going to, I think what I did is I subtracted x on both sides, so that gave me 2x, and then I subtracted 3 on both sides, and that gave me my 2, and then I divided both sides by 2, and I got x equals 1.